adjacency matrix. So what is adjacency matrix? What is incidence matrix? We will talk. So adjacency matrix, okay, let me have the graph example first, then we make the matrices. So graph, say how many points will be there? There is no rule. There may be 4, 5 or 6, whatever. So let us have 5. Let us have 5 points here. So these are the 5 points, and there may be some connections. Okay, maybe only one connection, maybe more than one connection. So these are the connections, and the graph is being made. Okay, so say this is our graph, and the points are A, B, C, D, E. Okay, points, that is vertices, will have names. So the vertices are A, B, C, D, E. 5 points, 5 vertices, A, B, C, D, E. Now there are some connections. So this is one graph example. And about this graph, if you think about adjacency matrix, you will, let me just keep this graph in the middle. So adjacency matrix will be a matrix, definitely, and that will be with the vertices as column and also as row. That is, there are 5 vertices in this graph, so there will be 5 columns and also 5 rows, like that. So these are the 5 rows and 5 columns. Now if you make the matrix, it will be like this. Okay, and we will matrix is just bracket, right? So this is the matrix bracket. So we will now check how many lines you have, from one vertex to the other vertex. So in this matrix, you will consider how many lines you have from A to A. That is, A to A, is there any line or not? So in fact, here we do not have any line from A up to A. So that will be 0, because no line from A to A. And how many lines A to B? A to B, you have one line. So that will be 1. So it is actually what? It is actually the number of edges. Adjacency matrix is actually the number of edges between vertices. So you have A, B, A, C, A, D, A, E, like that, and again B, A, B, C, B, 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 C, like that. So you can just count how many edges you have from one point to the other. So A to C, how many points you have? Only 1. You do not have any direction here, so this is fine. If you have direction, then adjacency matrix will be same, just for incoming and outgoing, like that. So let us continue with this. AD, there is no connection. No connection means it has to be direct edge. It has to be direct connection. So AE, it will be 2. AE, it will be 2. So you start with B again. So BA, again, it is 1. AB is 1. BA is also 1. Okay, and BB 0, and BC, there is no connection, and BD there is one connection, BE there is no connection. So in this way you can make the matrix, and that will be called adjacency matrix. So CA is 1 and CB is 0, CC is 0, CD is 2, and CE is 1. So you go to the next line. DA is 0, DB is 1, and DC is 2, and DE is 0. No, DD is 0, DE also 0. Okay. And the last row, that is E, and it is EA equal to 2, EB equal to 0, EC equal to 1, and ED equal to 0, and EE also 0. So this is the adjacency matrix. Now, if you have loop, what will happen? If you have loop, what will happen? So you can add all this together. I will talk about loop later, just wait. So if you add all these together, what happens? If you add the first row, it is if you add the first row, it is 4, and then it is 2, and then it is 4 again, and then it is 3, and then it is 3. So if you add up all together, it will be 6, 7, so it is 16, right? It is 16.
Yes, sir.
So this is the all summation, all the numbers added together, it is the 16. Now think about think about degree. What about degree? If you think about degree of A, what is the degree of A? 1, 2, 3, 4, right? 1, 2, 3, 4. What is the degree of E? That is 3. What is the degree of D? It is also 3. What is the degree of C? It is 1, 2, 3, 4 again. And what is the degree of B? It is 2. So what you are getting here? Summation of degrees. Summation of all degrees here. So all vertices degree summation. This is again 16. Do you understand? This is again 16.
Yes, sir.
So degree of A equal to 4, degree of E equal to 3, degree of D equal to 3, B equal to 2, C equal to 4, like that, and all together summation of degrees 16, and this is also 16. This is also 16. All number together, this is also 16. Okay. Now the problem is, if there is a loop, there will be a problem. So let us check with something. I mean, it is not with this situation. Let me use green color. Okay. If you have a loop somewhere, say with B, you have a loop. Say there is a loop with B vertex. Then what will happen? It will be number of uh, edges. Number of edges. This is number of edges. Number of edges from B up to B. So you will write B to B. So you will write B to B. B to B is 1. Okay. So this number will be 1. So when you have this number as 1, it is it is counted only one time. Okay. So it is counted only one time. Actually, this will be 3, and the total number will be 17, because there is no other option for B to B. Okay. Think about other ways. Think about other ways, like say, what is this one? You can say this is A to C. Possible, right? A to C. And this A to C is coming again. How coming again? You can think C to A also. A to C is 1, and C to A, that is also 1, and it is actually A to C, C to A. Two ways uh, in the matrix it is coming. But if you think about loop, that means the same point and same point. So this one is possible to count only for one time. So there is a problem with that. So when we cannot make the theory like summation of degrees will be always the summation of the numbers in the matrix. No, if it is with a loop, there is a problem with the number. So this is not a theory, but you can understand something. That is, in this case, if you have a loop, in this case, degree summation will be 18. In this case, degree summation will be 18. And the adjacency matrix summation will be 17. So you can understand one, that is, this is one difference. Degree summation is 18 and summation of the numbers in the adjacency matrix is 17. So we understand there will be one loop. There will be one loop in the uh, graph. So if there is two difference, then you will understand there will be two loops in the graph. So this is another information. Is that okay?
Yes, sir.
Okay, so let us remove the loop. Let us remove the loop situation again. I'm just doing undo and removing all the green color situation. So let us not consider the loop and go to the incidence matrix. That is the other one. So what will be the incidence matrix? In the incidence matrix, you will have one side as your vertex, another side will be edge. So normally we write the rows. Rows are the vertices. So one A, B, C, D, E. Rows are the vertices, and the columns are the edges. So you need to have names for edge. Names for edge. So every line should be named. So every line should be named like, so what you can give. Say we are giving uh, what E is already there. E1, E2, no. Say I'm giving L line. Okay, line one and line two. Okay, and then line three. This one is line four. This one is line. This one is, say this one is line five, and this one is line six. This one is line six, and this one is line seven, and the last one line eight. So you have 8 lines. One, two, three, four, 5, 6, 7, 8. 8 lines. So you will have to write all the lines here, all the lines here as columns. So line 1, okay, line 2, and line 3, and line 4, line 5, line 6, line 7, line 8. So all these will be your columns. Okay, all these will be your columns. So we will make the incidency matrix. How we will make the incidency matrix? We will just put 0 or 1. We will just put 0 or 1. That's it. So 0 or 1 means if there is any connection, then 1. If no connection, then 0. So very simple. The idea is, incidence matrix idea is, you will just uh, put 1 or 0. Okay, one means yes, and 0 means no. So what is yes, what is no? That means if if there is, if they are, let me write they are, that will be better. They are if they are connected. So you will take the vertex and the edge. So if you see that vertex is connected with that edge, so you will write yes. So now think about A and line 1. A and line 1. Are they connected?
Yes,
Yes. So,
sir.
so you will put 1 and then AL2. AL2.
It's
It is
also
also
connected.
connected. So it is
Yeah.
1. And AL3. This is also connected. And AL4. This is also connected. So fine. And L5, L6, L7, L8 are not connected. So that's it, finish. And go to vertex B. So B, L1 not connected, B, L2 not connected. So you can see B is connected with L3 and L5, L3 and L5. So L3 and L5 will be connected and other lines will be 0, 0, 0, 0. That's it. So about C point, what are the lines? L4 is the line, L6 is the line, L7 is the line, and L8 is the line. Okay, it has 4 degree, so there will be 4 lines. So 4 degree, 4 lines. Who are the 4 lines? L4, L6, L7, L8. So you will put L4, L6, L7, L8, and all others are 0. That's it. So this is the easy way to find out. Now you can think about D. So D will be 3, 5, 7, 8. 5, 7, 8. So you will put 5 and then 7 and then 8. That is 1, 1, 1, and all others are 0. That's it. So you will do like that, and E same. You have 1, 2, 6. 1, then 2, then 6, and all others are 0. All others are 0. So you will put 0 here, 0 here, 0 here, 0 here, 0 here. That's it. So this is called incidence matrix. And again, you can just sum up all the numbers for vertex. So for A vertex, the sum will be 4. For B vertex, the sum will be 2. C vertex sum will be 4. And D vertex sum will be 3. And E vertex sum will be 3. So this is actually, these are actually the degrees. These are actually the degrees. So all summation will give you the degree of vertices. Okay, so this is the thing, and you can have the summation of degree here. So summation of degree will be 16 again. So this is called an incidence matrix. Okay, so another thing I can tell you, age is also called incidence. Age is also called incidence. Okay, so that is all. Is that okay?
Yes, sir. Okay.
Now let me give you some special type of graphs. Okay, let me talk about some special graphs, and you already know those in computer network, that is topology. So there are some special graphs. Okay, some special graphs. Okay, so what are the some special graphs? Uh, Let me draw one by one and then you will understand. So one is called say one is called say uh, wheel one no wheel. Let me write the complete graph first. Okay, complete graph. So you may have you may have 3 points. So there will be just all the points connected. You may have 4 points, so all the points connected. So that will be the complete graph. All the points connected. Everyone is connected to everyone. If you have 5 points, okay, say if you have 5 points, so this is the 5 point graph, and all the points are connected to everyone. Everyone is connected to everyone. This is called yes. So this is called complete graph. You may have 6 points. So if you have 6 points, again in the same logic, every point will be connected with every point. So every point will connected with every point. So it will be like that. Okay. So it will be like that. Anyone missing this one? Anyone missing this one? Okay. And any more? No. So this will be called complete graph. In graph theory, the name is complete graph. So what do you call in topology? What do you call this in topology? Computer network. This this type of
Maybe
topology.
star topology, sir.
Is it star? What did you say? Star?
Star topology, sir.
This one star? No, I do not think so.
Sir, this one mesh topology, sir.
Exactly. This one is mesh. It is not star. It is mesh. Okay. So this is a special kind of graph. One complete graph. This is one type. Okay, special type of graph. Let me tell you another graph. It is called cycle. It is called cycle. In graph theory, it is called cycle. So what is the cycle? If you have 3 point, the cycle is like this. It is the same thing like complete graph. And if you have 4 points, the cycle will be like that. If you have 5 points, the cycle will be like that. Okay. If you have 6 points, the cycle will be like this. Okay. So this will be called C3. C3 means 3 vertex and cycle, and C4 and C5 and C6. And complete graph is called like K3, K4, K5, K6. So what you call in computer topology, the cycle? What is the name in the computer topology for this?
Sir, circle topology, ring topology, sir.
Ring. It is not circle. In the topology computer network, it is called ring. So this is another special type of graph. Another special type of graph. Let me give you another special type of graph. Let me just erase this part, or I'm not sure. I mean, I just make it little squeezed, then what will happen? Okay, so let me write another type of graph. It is called the wheel. It is called the wheel type of graph, wheel graph. So in the graph, it is called wheel, and it looks like you do not have actually 3 point wheel. You have 4 point wheel minimum. Okay, and you may have 5 point wheel. So that will be the 5 point wheel. So one will be in the middle and other will go to the other side. So there may be 5 points in the boundary and you have 1 point in the middle, and the boundary points are also connected. So this is another one, and you may have 6 points in the boundary line and you have 1 point in the middle. So if you have 6 points in the boundary line, say it is like that, 6 points in the boundary line, those are connected. It is like a cycle, and also there will be one in the middle, and from the middle point all the boundary points are connected. So this is uh, another one. So you can call this W4 and you can call this W5 and you can call this W6 and it is W7. So it is called wheel. So what is the name in the uh, computer topology?
Star topology, sir.
This is called star, correct. So this is called star topology. So these are the special type of graphs. Sometimes we use this, sometimes we can use, but all these are simple graphs, right? All these are simple graphs. So wheel or cycle or complete, all these are simple graph. And you can in computer topology you can have something like this, that is just one line, okay. And this type of graph does not have a specific name in graph theory, so we are not talking about bus topology. So these are the different names only. You already know, you already understand how the graphs are connected. So fine, you can easily find out the vertices here. Okay, what will be the vertex of one point, vertex of other point. So this is not a big problem. It's very simple. Another special graph, it is different. It is not like this, but it is a duplicate presentation of a graph, and the name is called bipartite graph. So this is different. This is not wheel, not star, not complete. It is different type of graph, a special graph. So it is called bipartite graph. So I'm writing the definition here. What is bipartite graph? So bi means two and part means two part. Okay. So it is actually the graph which can be uh, presented with two uh, groups of vertices uh, where there will be no edge between uh, vertices in the same group. So this is the definition. So what I mean actually by that, so I will tell you and then you will understand. So this is the definition of bipartite graph. So any graph can be bipartite or not bipartite. Any graph can be bipartite or not bipartite. So what does that mean? The meaning is there will be two groups of uh, points. Say in one group you have 2 points A, B. In another group you have 3 points C, D, E, or any name. Name is not important here. So the condition is there may be connection with different group vertex. there may be connection with different group vertex, but not same group vertex. Okay, so you may have one connection, you may have two connection, no problem. You may have connection one or more between the vertices in two groups, but there will be no connection in the same group vertex. So if you think about this group, you have no connection in this group. If you think about this group, you have no connection between the points of this group. So that is the condition. But you may have connection with different groups, no problem. So in this case, we see there are 5 points A, B, C, D, E, and 2 points are in one group, 3 points are in other group. So this is the situation we can call bipartite graph. Now this graph can be also also in a different, I mean, presentation. Say I'm just showing this, then you will understand. Say I am taking one point A, okay, according to the graph. A is here, and you have say the points are not in separate groups. Points are just like that, A, B, C, D, E. Okay, so you have points A, B, and C, D, E. There are 5 points. Now, if I draw the graph again, if I redraw the graph, so A, B, they are connected and they have two connections. Okay, fine. So I am giving two connections, A, B, and AC connected, only one line. So AC connected, only one line, and CD connected, only one line. Okay, then fine, CD connected, and DE there is no connection, and E will have two connection with A. So E has two connection with A. So E has two connection with A, isn't it? So any more missing? AC is already there. CD is already there. Anything missing?
No, sir.
No, it is not missing. So if I give this graph, if I just tell you, okay, I'm giving you one graph and this is your graph, and tell me, is it bipartite or not? So this is the question. Then you will think, okay, is it possible to present like this? Is it possible to present like this? Okay, possible to present like this. That is two groups of vertices, and then there will be no connection between the vertex in the same group. So if it is possible, then bipartite, yes, you will say yes, bipartite. If it is not possible, then it is not bipartite. So this is another special graph, and that is it. Now the point is, how can I understand? There may be different very critical type of graph or many points. So how can I understand? So this is very simple. In a simple way, you can just do this. Let me just show it to you. Let me just show it to you here. Okay. So let me just give you another graph so that you can understand. Not have enough time. Okay. So there may be 5, 6, 7 points. Okay. So it's like that. Let me have some examples like this. Okay. So you have A, B, C, D, E, F points. So what you do, you start with any corner. You start with A or B or C or D, any point, no problem. You start with one point. So you start with one point, put this in one side, and this is your A, fine. Now think about the other points. So you have A, B. So put B in the other side, other group, and AF. Put AF in the other side, AF. And another point is C. So put C in the other side also. So you have two connection AC. So give two connection, and this is C. Is that okay? Start with any point and then put the other points in the other group. Now you go on. About B. So do you have any other connection? No. B has no connection. Fine. About F. What are the connection? One is with A, another is with D. So you have put the D in the other side. So D in the other side, and how many connection? FD 2. So use 2 connection. Fine. And then again move on with D. So D will have a connection with F, and at the same time it will have a connection with E also. So E is here, E is in the other side. So DE one connection. Fine. Now think about D, no more connection. Fine. And what about C? You have one connection with A, 2 connection with A, and 1 connection with E. So this is a problem, right? You have to give this because CE are connected. So just because of this line, it is not bipartite. So that is how you can just check one graph is bipartite or not. I mean, 2 group separation possible or not. So this is all for today. And if you have any question, I can discuss again tomorrow. So let us finish our class here. We will continue with the topic bipartite, maybe a little, and then some new things in the chapter. Okay then.